Okay, so we have a very similar looking logarithm problem to the previous example. So over here, if you want to solve for x, we can try to group the logarithms together as long as the bases are the same. So the 3 over here, the 3 over here. And so we can actually add the logarithms together by multiplying what's inside. So we're going to get log base 3 of x times 2x plus 1. And the entire bracket, this is equal to 1. Okay. In this case over here, let's try a separate a different kind of technique. It might become useful at another point. So I'm just going to introduce this part over here. Now, if you ever have a constant, this can actually be converted into a logarithm. So if you have a whole number, it's really just the log base of some number, and the inside is the same number as well. And this is actually still 1. And of course, the left-hand side, I haven't really changed anything. Still x times all of 2x plus 1. And the reason why I'm doing this is because, well, I mean, the two logarithm bases are the same. So this means what's inside the bracket must also match up. So we're going to have x, actually let's expand what's inside. So 2x squared plus x is equal to 3. Okay, and if that is the case, then solving this just means that we're solving quadratic. And I'm just gonna grab the 3 to the left side. So when we solve a quadratic, it's nice to have everything on one side. Okay, let's see, how can we solve this one here? Maybe I'll just use quadratic formula. Not feeling the cross method at the moment. Okay, so minus b, we have minus 1. So plus or minus b squared, so 1 squared minus 4. A is 2, and c is negative 3. Divided by 4. Okay, to keep going over here, we're going to have negative 1 plus or minus square root of 1 squared. So you can see it's plus over here. We'll just do that in a different color. So we have double negatives. So 1 plus, so 8, 24, 25 is inside it. And this is over 4. Okay, so we have the square root of 25, which is 5. So we have either negative 1 minus 5. We'll say that first. So we have negative 6 on 4. Or negative 1 plus 5, which is 4 on 4. So two solutions here. You can say x is equal to negative 3 on 2 or 1. Now, you may think we're done over here, but the trick here is that we're solving for x, right? Now, what values can x take? In this case over here, we've got to scroll all the way back up to our equation. And over here, remember that what's inside the logarithm bracket must be positive. So what's inside this bracket over here has to be greater than 0. Otherwise, the logarithm is undefined when it's 0 inside. And it just, well actually, it's also undefined if it's negative as well. It has to be a positive number. So, two criteria over here. One is that x must be greater than 0 for the first x over here. For the 2x plus 1, well, you can solve the inequality over here. So 2x plus 1 has to be greater than 0. And this means that x must actually be greater than negative 1 on 2. And just to clarify on that, over here, let's have a look. So it seems like 1 is okay. What about this negative 3 on 2? Is this greater than negative half? No, it isn't. It's a larger negative number, which means it's actually lower on the number line. So this means that we need to actually reject this solution as negative 3 on 2 is less than negative half. So the only solution here for this problem is only this one here. So only x equals to 1 is a viable solution.